Hello, welcome all. This is Abhilash. So, welcome all to this session. In this session, we are going to discuss the simulation techniques. Well, let's understand what is the simulation, the meaning of the simulation. Simulation is a imitation of some real thing or a process. The act of simulating something generally involves representation of certain. The act of simulating something generally involves representation of certain key characteristics or behaviors of selected physical and abstract system. Simulation involves the use of models to represent real life situation. The act of simulating something generally involves representation of certain, that is the characteristics or behavior of the person. A simulation imitates the operation of real world process or system with the use of models. The models represents the key behaviors and the characteristics of the selected process, while the simulation represents how the model evolves under different conditions over time. Simulations are usually computer based using the software generated model to provide support for decisions of managers and engineers as well as for training purpose. Simulation techniques aid understanding and experimentation as the model are both visual and interactive. Simulation systems include discrete event simulation, process simulation, dynamic simulations. Businesses may use all of these systems across different levels of organization. A simulation model is a mathematical model that calculates the impact of uncertain inputs and decisions we make on outcomes that we care about, such as profit and loss, investment returns, and many more things. A future of the company also you can consider, which can be derived from the simulation model. A simulation model will include model inputs that are uncertain numbers, uncertain variables, intermediate calculations as required, model outputs that depend on the inputs. These are uncertain functions. Simulation techniques can be used to assist management decision making where analytical methods are either not available or inappropriate. Typical business problems where simulations could be used to aid management decision makings are inventory control, queuing problems, and production planning. A major application of simulation has been in the analysis of waiting line and queuing systems. Since the time spent by the people thinks waiting in the line is valuable resources, the reduction of waiting time is an important aspect of operations management. Waiting time has also become more important because of the increased emphasis on quality. Customers equate quality service with the quick service, and providing quick service has become an important aspect of quality service. For queuing systems, it is usually not possible to develop analytical formulas, and simulation is often the only means of analysis. Simulation can hence be used to investigate problems that are common in any situation involving customers, items, orders arriving at given point and being processed in a specific order. For example, customers arrive in a bank and form a single queue, which feeds a number of service days. The arrival rate of the customers will determine the number of service days to have open at any specific point in time. A queue system can be divided into four components, that is arrival of the customer, concerned with how items arrive in the system, the people, the customer, the cars, the products, that all are considered under the arrivals. The queue or waiting line, the concern with what happens between the arrival of an item requiring service and the time when service is carried out, right? Waiting line be considered for the customer as well. He can wait for his bill when we go out for the window shopping in the mall or in some clothing shops, right, for purchasing some cloth. That time we waited for our number to get the bill paid, right? Then service concerned with the time taken to serve a customer, right? Service is an important aspect of the business of any service. Without a service, there is no business. Outload or departure, the exit from the system, the delivery, you can say the product has to be delivered at the customer's door, that is also called as a departure. A queen problem involves striking a balance between the cost of making reductions in service time and the benefits gained from such a reduction. There are a number of structure of queuing systems in practice. We will study only one, that is a single queue and single service point. Single queue, a single service point, queue discipline is first come and first serve. That means if some customers has stood up in the queue, as his number came, he will be served as the first. Arrival are random or for simulation, this randomness must be taken into account. Service time and random service times are random, and for simulation this randomness must be taken into account. Inter-arrival time is the time between the arrival of successive customers in the queuing situations. Service time is the length of time taken to serve customers. What is the purpose of random numbers? There is a randomness in the way customers are likely to arrive. The service time in most of the cases is also variable. The purpose of the random numbers is to allow you to randomly select an arrival or service time from the appropriate distribution. To account for randomness and random numbers are used. Such numbers can be computer generated and are often listed in published statistics tables. Here we have a set of random numbers. You can see the three rows with the numbers 89 07 37 29 28 08 75 01 21 63. So these are the random numbers, and we have a three setup of numbers, and in each setup we have a 10 numbers, and that all are the random numbers. These random numbers are displays as two digit numbers in the range between 00 to 99. Every number is equally likely to occur, and there is a no pattern, and thus no way of predicting what numbers will be next in the sequence. The arrival time of a customer at a retail sales depot is according to the following distribution. You can see the minute time in the inter arrival time, that is the IAT, and the probability of the customer is a 0.1, 0.2, 0.5, then 0.1 and 1. And under the service time, that is also the numbers are in the minutes. The time is written in the minutes, and the probability is 0.3, 0.5, 0.1 and 0.1. This simulates the process for 10 arrivals. So this all are the 10 arrivals, and estimate the average waiting time for customer and percentage idle time for the server. So use the following random numbers for IAT, that means interval arrival time, that is a 25, 19, 64, 82, 62, 74. So all these random numbers are used for the inter arrival time, and for service time we have different numbers. Assume that shop opens at 9 a.m. in the morning. So how much time they get to serve the customer? So let's have a calculation here. Calculation on basis of random allocation. Arrival time, we have a probability of 0.1 at the arrival time 3. So cumulative probability is 0.1, and the basis of random allocation is 0.02 to 0.09. So there are all random allocations have been mentioned here. So let's go back in the last slide. You can see the numbers which are from the 00 to 99. All are the two digit number, and these all are the basis of random collection which has been done. Okay, so the service time is taking how much service time they are taking for the servicing the customers. You can see 3 4 5 6. 3 4 5 6, the probability of 0 0.3, 0.5, 0.1 and 0.1. So cumulative probability is 0.3, 8, 9 and 1, and the basic of random calculation is 0.0.2 to 0.029. Okay, so what they are done, the community probability has been mentioned here. So they have deducted this probability from the this community probability. So the number has become like 0 point like mine from 30, it has been divided by the 0.30. So the numbers are coming as 0.0 to 0.29. So like that numbers are getting from 1 they are divided to 0.1. So last digit the basic random allocation should be 0.9 to 0.99. Okay, so again inter solution, you can see the basic or random allocations here as well and the below as well. So you can see the customer 1 2 3 4 5 to 8, 10 and their random numbers as well that we have seen in the last to last slide. Here in the bottom we can see the numbers. Okay, so that is interval time, arrival time is 4 4 5 5 6 6 6, that is also random. This random numbers also random, and the service time is the 6 4 4 4 4. Okay, so here you can see the time of arrival. First customer has come when time is the when clock time was 4. That means the shop opened at the 9, and the first customer came at the 4 minute after 4 minutes. So the time is the 9:04. Service time is also same 9:04, and service end time is the 9:10. Okay, so each customer is getting 6 minute time. Here you can see this in the middle of the this solution, we can see the service time column. Their time has been given. So 9 4 plus 6 is equal to 9:10. So each customer has this first customer has taken the 6 minutes to complete the service. Okay, so this is how the calculation has been done. You can see this, the total time has been given is the 53 minutes. Total waiting time was the 4 minutes, and total idle time was the 12 minutes. So idle time means the customer, when customer came at 9:04, so shop open at the 9, so be 9 to 9:04, there was a 4 time, that was the idle time. So and when there was a gap between the first customer to second customer, so between that gap period is considered as the idle time. Okay, hope you got this solution. Okay, so average waiting time for customer is 4 by 10, that is the 4 minutes, and percentage average for the service is the 4 by 53 into 100, that is 22.66%. Okay, so that is calculated based on the 12 by 53 total time divided by the idle time into 100. So we got a 22.64%. Okay, so thank you. Still someone is having doubt, they can connect with me. Thank you. Best wishes.